the strongest source of gravity in the known universe. The most extreme objects floating out there in the darkness, completely invisible, pulling in everything and anything that passes too close. But, as dangerous as they seem, we've never actually observed a black hole. Why is that? And how do we know they're actually out there? A black hole is a region of space where gravity is so strong that all matter caught in its pull falls inside. Black holes were first predicted mathematically by Einstein's theory of general relativity. However, they've actually been around since the 18th century, when scholars John Michell and Pierre Laplace both separately talked of stars whose gravity was sufficient enough to pull even light into it. If we are ever to see a black hole, and I'll get to that in a couple minutes, what we would actually see is what's called the event horizon. It's the boundary between life and death. Anything past the event horizon experiences gravity so strong that the escape velocity is greater than the speed of light. And since the speed light travels is the cosmic speed limit, which by the way is 186,000 miles per second, nothing can escape past the event horizon. Escape velocity is the speed an object needs to achieve to be able to free itself from a planet, stars, or black holes' gravitational influence. For example, on the surface of Earth, rockets need to have a speed of about 25,000 miles per hour to achieve escape velocity and reach outer space. However, the escape velocity needed to pass the event horizon of a black hole is greater than the speed of light. That's why black holes are invisible. There isn't any light from the black hole that can escape and reach us. So, how do we know they're there if we can't see them? Because of their influence on other objects. Since their gravity is so strong, we can observe its effects on nearby objects. Light gets bent around the black hole. Nearby stars have extreme orbits. Or the stars can be consumed by black holes altogether. Black holes can also grow in size. Basically, the more matter they swallow, the bigger they get to fit all that new stuff. This means that over billions of years, a black hole can swallow so much matter, it becomes what's called a supermassive black hole. They are the largest type of black hole known, and can get up to billions of times the mass of the Sun. They are thought to be at the center of every galaxy in the universe, and we're about to take a picture of the one in ours. The center of the Milky Way contains a supermassive black hole called Sagittarius A star, and we're pointing a telescope right at it. The Event Horizon Telescope is an international collaboration linking astronomy facilities from all over the world to create one Earth-sized radio telescope that will be powerful enough to pierce through the thick dust layers at the center of our galaxy and observe Sagittarius A star directly. We've already collected enough data, and scientists are working to clear away the irrelevant information to get a hold of what we really want: the picture of our supermassive black hole. We expect to see a bright accretion disk surrounding the black hole, and almost like a half-crescent moon, we'll see a black sphere almost completely overtaken by the glow of the superheated dust. There will be the event horizon, our first image of a black hole.